let's talk a little bit more about the angle in this magnetic flux formula. We're supposed to multiply magnetic field times the area that's enclosing a certain amount of magnetic field times the angle between the magnetic field vector and the vector that works for the area that we're describing. Remembering that the vector that defines the direction the area is pointing is a normal vector perpendicular to that area. But you're probably not going to get homework problems which tell you the angle between B and A is such and such. That's too easy for you. They're probably going to give you problems where they say that the plane of the area makes an angle with the magnetic field, and here's a number for that. You need to know that 90 minus that angle that they just gave you is the one that you're looking for. So let's just visualize this in this way. Let's say here I've got a bunch of coils that are flat in a plane. So we can describe this flat piece of paper as the plane of this much area. That's what I'm concerned about when I'm talking about direction relative to a magnetic field. So we've got to pick a vector that's normal to this plane, pointing perpendicular to it. Okay, so I'll just make that happen. Okay, so there. Now there's my supposedly flat area with a normal vector pointing out of it, perpendicular to the plane of the coils. And the next question that comes up is, what is the angle between a magnetic field and that plane? So if the pen is describing a magnetic field that points in this direction, then right now, if the magnetic field is in that direction and the coils have an orientation in this plane of this paper, some book could say that for this problem, the magnetic field makes 90 degrees with the plane of the paper. Fine. Then what is the angle between my normal vector to that plane and the magnetic field? There is no angle between them. That angle would be 0. You would put 0 into your cosine formula, and you would get cosine of 0 is equal to 1. That's telling you that you're getting the maximum amount of flux when you're lined up like this. All right. What happens if I rotate this by 30 degrees? Now, the textbook might say that you have a problem where the plane of the paper is making what angle with the magnetic field? All right. If this is 30 degrees, the homework problem might be telling you that this between the magnetic field and the plane of the paper is a 60-degree angle. You need to know if the plane to the magnetic field is 60 degrees, then what you want to put into the formula, into the cosine, is going to be 90 minus 60. You want to put in 30 degrees to make that happen. Let's make this rotate again. Okay, now my magnetic field is going along the plane of the coils. Is there flux through the coils? No, because there's no perpendicular part of the magnetic field that is going through the coils. The magnetic field lays flat in the same plane as the coils. The angle between the magnetic field and the area is not 0 because the direction of the area is this direction. Therefore, the angle between the magnetic field and the area is 90 degrees for putting into this formula. Cosine of 90 is 0, and that's what you should be getting when there is no perpendicular magnetic field going through that area. Now, if I rotated this again by 30 degrees, going from here to here, then the angle between the pen, which is the magnetic field, and the normal vector for the area is 90 degrees plus that 30 degrees. You would put 120 into your cosine formula. And if you rotated all the way back in this direction, now your normal vector for the area is pointing in exactly the opposite direction of the magnetic field. This would be a theta value of 180 degrees. Now you do have a maximum amount of flux going through this area, but if you started in this direction, then rotated around 180 degrees, then what you're going to put into this cosine value is 180. Cosine of 180 is -1. This is going to tell you that you have negative flux. And that's because you had maximum positive flux when you were oriented like this, and you decided n hat pointed in the same direction as the magnetic field. Then you stick with that even when you're rotating this around and the magnetic field and n hat now point in opposite directions. That's going to be maximum negative flux compared to how you defined things when you started.